Welcome CHEM200L. This is the pre-activity lecture for Activity 8. Please note a couple announcements. Experiment 3 post-lab is due on October 12th, at the beginning of class. Be aware of the schedule. There are 4 activities in a row, which will be nice. A little bit of a break, but then there are 6 experiments. Lots of lab reports are coming in your future, so plan accordingly. Please note, Monday, October 5th, there is no Zoom meeting or office hour. This video is in replace of that, so your activity is still due at the end of that day. There will be a lab report follow-up. What this means is you can schedule an appointment with me, and we can talk specifically about your lab reports, the comments, grades, so look for an email to schedule that. So today I'm going to talk about that lab report follow-up and Activity 8, and you can see this prepares also for those in lecture exam 2. So if you do this activity early, it might help you get ready for the exam. So lab report follow-up, this is a good time to reflect on how lab reports are going. Usually if you're in class, would say let's have a lab report quiz, and I would say list everything required for a pre-lab, data observation, and a post-lab. I know you have access to the lab guidelines. You have resources when you write lab reports. I think it helps to know, though, right away what belongs in each section. So that's why this is a good check-in. Think about, without looking at any notes, what goes in every section. As I mentioned, you'll get to set up an appointment if you want, and we can talk about your lab reports so far and prepare for those next 6 that are coming. One of the main objectives from this class is to learn to write scientifically. So that's the emphasis here. I do have on my website several journal articles that I've published and my dissertation, so you can see what you're doing, learning to write scientifically, carries over to scientific research that goes into journals, dissertations for PhDs. So this is some really important fundamental things that you're working on. Alright, so Activity 8 has a table that looks somewhat like this, and I'm going to go through a couple of examples for you and just want you to see the steps so then you can complete the activity, and then again if you're in lecture to prepare you for exam 2. So first thing, the steps, remember, are to count up the valence electrons, and we've got 5 for nitrogen, 7 for each fluorine, so that gives a total of 26 electrons. This Lewis structure part, you're not really concerned about the shape, so you can draw it just to get the electrons around the terminal atoms, and then if you've got them left over, put them on the central atom. Now the molecular structure is really where I want to see what does this molecule look like. So you can see that the lone pairs aren't included. It's just the shape. You could make this shape a little more three-dimensional if you want, but you're not going to be graded on your drawing skill here. It's just, do you have a representation of what the molecule looks like? If you have a model kit, that would be helpful. If you have toothpicks and some marshmallows or candy, you could also help with this. Whatever it takes to visualize this, I think, is really key. The next, look at the terminology: electron geometry, molecular geometry. So electron geometry, we look at the central atom and we can see that there's 4, so that's tetrahedral. And the molecular geometry has a lone pair, so it's not okay just to put trig. We have to be very clear that's trigonal pyramidal. If it was just tetrahedral, it'd be 109.5, but again, that lone pair is taking up space. So you can say it's less than 109.5. And for this last piece, I want you to classify, is it polar molecule, is it a nonpolar molecule, or is it a polyatomic ion? Some of them will be ions, so you don't have to calculate anything, just put ion. So here we need the electronegativity, which is 3 for nitrogen, 4 for fluorine, so that is a polar bond, and because of this shape, they are not canceling out, so that is a polar molecule. The other example here is formaldehyde. So that's 4 for carbon, 1 for hydrogen, and 6 for oxygen. That gives us 12. Central atom, least electronegative, that's not hydrogen. And you can see we don't have enough electrons to go around, so I'm adding double bonds and then filling out octets. Same thing here for 3-dimensional. You don't need the lone pairs in, we're just showing the shape of the molecule. The electron geometry, there are 3 electron regions, and there are 3 bonding regions, so both of these, we need to write them out both to emphasize that you know they're both trigonal planar. This would normally be 120 degrees, but again, these double bonds take up more space, so you can see that would squish the other a little bit. That would be 120. For polarity, remember we've got to look up electronegativity values. That's 2.5 for carbon, 2.1 for hydrogen, and 3.5 for oxygen. So we can see that this is a nonpolar bond, this is a nonpolar bond, but what we do have up here is a polar bond pulling in that direction. So overall, this would be polar as well. So this is what you'll be doing for Activity 8, completing the table. So I encourage you, if you've got contact information for classmates, work on this together and complete it and turn it in by the end of the day on Monday.